Hey guys, back again. This is the second video in this little series on computer and network systems. And this particular one is going to focus on networks and different types of networks and topologies and some of the core components we need to make a simple network go. So firstly, I guess understanding what a network actually is, and with from our previous video, we know there's different types of computing devices. They have different architectures and different sort of main uses and purposes, designed in different ways. We want them to be able to communicate and talk to each other in some way, to be able to share resources. They might be printers, internet connections, files, all sorts of things, or obviously communications as well. That's a big important reason of why we connect computers to a network. All about sharing and communication. So that's really what a network is all about, and there's a definition there of what a network is. There's different ways, like computers, and there's different architectures for computers. There's different architectures for networks as well. So we're going to explore some of those main architectures. And really, I guess the early networking architecture was this one, peer-to-peer. Essentially using a cable to connect from one computer to the next, and often from a server to a workstation, then to the next workstation, to the next workstation, to the next workstation. And you might have a printer plugged off in there somewhere as well. But there wasn't really a central storage server, so to speak. There might have been a main computer in that sort of network, but essentially they were all nodes on that network in a peer-to-peer arrangement where they were all sort of pretty much at the same sort of level. Incidentally, some terms there in networking, the bold terms, they're significant, so you need to use those terms. A node is just a device connected to a network. It's sort of sometimes also a client is another term used to describe any device connected to a network. And then we've obviously got server and workstations. So servers are main computers on networks that do specific jobs on that network, and then workstations or clients, devices that connect to that network. So peer-to-peer networks connected similar to the image shows there, just from one to the other to the other. Very cheap, very simple. No real serious expertise in networking involved to set that up. You didn't need an expensive server, so you could create a network, and those devices can share content and resources and devices like printers and those sorts of things really quite easily, but it's not terribly sophisticated. So certainly the individual computers can take a hit on their performance, and in the early days of computers that was an issue. Because you don't have a server, you don't have anywhere to centrally back up files. You've also got issues with one of the nodes not being on or being turned off, can impact the rest of the network, and you certainly, if that node is off, you can't access any of the files or resources that are shared or connected to that one workstation, even if the rest of your network might continue to run. So in other network designs, those issues can be rectified. But this simple peer-to-peer network model, early stage of networking, this is sort of the way it was done. But some of those issues and limitations really meant we need to come up with a better way to connect our computers together to achieve this sharing and communications stuff that was the desire. So we really moved into a local area network as kind of the next way to network our computers together, and this is still pretty much the dominant way that we do networks today. So if you think of our school network, this is in a local area network arrangement. And LAN is obviously an acronym for local area network, also known as a client server network, because we've got client devices, workstations, laptops, iPads, phones, all those sorts of things connecting to our network, and we've got servers doing various jobs on our network that are quite important, like storing devices and having people authenticate and hand out IP addresses and all sorts of things like that. And the network function is controlled by that central server, or in larger networks like ours, multiple servers. But certainly a simple LAN can work with one server that performs all of those central network jobs. So the benefits are that obviously that server can be a central storage location for all files, which means it doesn't then matter whether a particular workstation or client on the network is on or off. All of the others are able to access those stored files centrally. Similarly, resources like sharing of printers and internet connections, all that stuff can happen from that central server, which any of those devices can do, regardless of whether any of the workstations or clients are on or off. So all of that kind of works. You also start to get some economies of scale with LANs as well and networks, because you can then start to license your software in volume arrangements, which makes it cheaper than going and buying a copy of a piece of software for every workstation on the network. So you can benefit economically as well, and it also allows you to implement some security protocols. So you can have users not able to, or workstations not able to access certain resources or functions. So it allows you those sorts of benefits. Obviously, can still get quite expensive on a large scale. If you've got really big networks, it can get a little bit expensive because the equipment and the quality and the capabilities of the equipment increases as you've got more clients on a larger network, and the cost of that obviously goes up as well. As they get more complex, you kind of need to have some specialist knowledge to be able to manage this type of environment. So it means specialist staff to run things here who have some knowledge in how the network works and what to do if things go wrong. Failure of servers becomes an issue because they're so important and critical to the functioning of the network and the storage of data and all those sorts of things. If a server fails, that's usually really bad, a big deal. So you need to make sure you've got backups and things in place, and alternate arrangements and redundancy embedded into your network, so that you can deal with and recover fairly quickly from a server failure. So there's a lot to start to consider, particularly as your LAN gets much larger. And monitoring security and making sure that different devices and users have access to only the stuff that they need. Obviously, somebody needs to make sure that that's all maintained and looked after. Venturing into then beyond LANs, a wide area network, or a WAN, is really when you start to want to connect two or more local area networks together. So if you imagine a large corporation with offices in different cities, within each office they might have their own local area network within that particular building or that office. But because they're all part of the one organisation, they all want to be able to communicate and share stuff with each other, even across cities, within cities, but also even internationally, different branches of the same company in different countries. So to be able to connect those LANs together, the concept of a wide area network emerged, and that's sort of demonstrated in the little diagram there on the right, where we've got 4 different LANs all connecting together. Those LANs can be in different cities, they can be in different countries, they do not have to be in the same geographic location, and we can connect them together. So WANs are about spanning networks that span large geographic areas, and they're typically divided into different LAN segments. To create that connection, to connect LANs together to form a wide area network, you need a router. That is the job of a router. The router connects LANs together and directs traffic between those local area networks over the wide area network. And classic example of this is the internet. The internet is the ultimate wide area network. There are local area networks all over the world that are all connected together using the internet network. And so what you're really talking about is a massive global wide area network. In our context, our local school network is a part of the wider Brisbane Catholic Education WAN, which connects all of their schools together, and that enables Brisbane Catholic Education to deliver services centrally out to all schools. So that's an example of where a WAN can work. So certainly it can allow sharing of files and resources, but not just between computers, but in fact across local area networks. And you can expand it. There is really no limit to where those LANs can be, that they're able to be connected anywhere on the globe. So that's quite a significant advantage. But as you could appreciate, I'm sure that the cost of doing that can be quite significant. So they can be expensive to run. So there's certainly more something that you see in very large organisations that have the the capacity to do those sorts of things. And obviously, as with anything that gets larger, the complexity increases, so they become more complex. And again, and I guess another level of specialised people to manage and run and set up those types of networks. So when we're talking about networks, it doesn't matter what type of network you're talking about, every network has what's called a topology. So that refers to the layout of the nodes in that network and how they are connected together. So network topology talks about how these things are connected. And there's different topologies as well. A couple of the earlier ones were the bus topology and the token ring topology. Bus topology kind of fitting for the peer-to-peer network, I suppose, more than anything, in that all of the nodes on the network were along the single cable or a bus, the data pathway. We learnt that from the last video. Stretching from one node to the next, really simple, really cheap to set up and run. But the problem was if one of those nodes went down, the rest of the network would be out as well. So that's the problem with the bus technology, the bus topology. Token ring topology was kind of an attempt to address that in some ways, where the nodes would be set up in a ring configuration, almost like a circle, rather than from one to the other. And that meant that the way that the token ring worked was that data being sent were in packets. So a packet is another term for a piece of data being sent around a network, and we'll explore packets a little bit in the next video. They would be addressed to a particular node on the network. So the address of where that packet needed to go was addressed. So it knew where it was meant to be, which computer in the network was meant to get it. And the different clients would read the token, and the one that it was meant for would go, oh, that's me, and it would take that packet. So it would recognize it and it would take that packet. So that's kind of a way of overcoming the limitation of the bus topology, using the token ring topology. But again, still lots of limitations, certainly scale being the biggest one. Doesn't really scale very well to lots of clients in the network or in over larger areas. So there's ways to overcome that. Was really to develop where we are today, essentially, in the star topology. The star topology is really where we still are now, and our dominant topology in organising and structuring our networks is to have them organised in this star configuration, where from your central server, if you like, or your central hub on your network, all of the nodes are connected directly back to that central location. And you think about it, it sort of produces a big star where from that central location, branching out into each individual network section or each node, there's a cable to make, or wirelessly in some cases, to create that connection. So we need different equipment to set up this kind of network, and that's where these switches, the devices called switches, come in. Because they allow the data to be passed onto each specific node on the network, and you can get a lot more control over the flow of data around a star topology network and be quite specific about what clients on a network directed traffic rather than having it broadcasting to everyone. It can be a lot more controlled and a lot more specific. So they're the three different topologies to be aware of. There are others. But the star is certainly the topology that we use in modern networks, and token rings and buses are examples of ones where we've come from or started fairly easily. So here is, I guess, sort of an example, I suppose, of a network set up in a star topology. Now, this might represent something similar to even a network you might have at home, for instance, where you've got a central server just here, connecting to a switch, and then all of the other network segments, like you can see these desktop PCs, all connect back into that switch, as does the modem supplying connectivity to the internet with a little firewall in between for connection. And then these segments here are connected via Wi-Fi for these devices, your smartphones and tablets and laptops and things, but they all come back through the switch to the main central server. So you can see that where the sort of star topology is in play there, even though it doesn't sort of look like a star, you can follow all of the connections back ultimately to that central one central point, and that central server and switch that is managing all of the traffic around that particular network. To make all of this happen, there are some key pieces of equipment that you need to be aware of, and these are the 4 key pieces of equipment that we're going to need to know about to construct some simple networks. And obviously a modem is an important device, because a modem is what connects you to your internet connection, to your internet via your internet service provider. Modem is a term that's actually short for modulator demodulator. Take the MO from modulator, the DEM from demodulator, put them together and you've got modem. A modem is a device that converts signals to be sent, electrical signals, computer signals, over the phone line, and then also to receive phone line signals and then convert them back, demodulate them back into electrical signals that your computer is able to understand. So because our internet services are delivered to us by telecommunications companies using our phone networks, we need those devices to be able to convert those signals to and from, electrical and phone signals, so that that internet network can work. A switch is a device on a network that reads packets of data and the address applied to a packet of data and directs those to the node that they are addressed to. So in larger networks, that creates more efficiency on the network. You don't want broadcasted packets out to everybody, like the sort of the token ring and the bus concept, and nodes having to look at that and go, oh, that's me, take that. Switches allow that to be a lot more specific, and they go directly to the node that they are addressed to. Less traffic, more efficient on your network, makes everything work more effectively. And switches also allow you to connect different segments in your LAN together back to that central point. Okay, so you can start to break up, or you can have larger networks broken up into smaller segments, which makes it a little bit easier to manage. And the switch allows you to manage that star configuration so that everything ultimately goes back to that one central point, which is the purpose of the star topology. Routers are devices that are used in WANs. So we looked at WANs before, multiple local area networks connected together to form a wide area network. And at each one of those LANs, you need a router to be able to create that connection off to those other wide area networks. So routers are a really important job for that. It directs traffic across the WAN to the LAN that it's got to get to, and ultimately to the client device or to the node on the destination LAN that requested that packet or that data. A router also allows you to share an internet connection across multiple devices and across a network. So you've got one internet connection coming into your network, and you want that to be available to all of the devices on that network. You need a router to be able to do that sharing. Okay, that router is a device that, as well as connecting your WANs together, allows you to take that internet connection, that single internet connection, and share it out to all of the devices on your network. You would most likely, if you've got a wireless network in your house, you would have a wireless router that is creating that sharing capability and probably doing it wirelessly. Which brings me to wireless access point. So a wireless access point is exactly that. It plugs into your switch or router and extends that LAN connectivity to wireless capable devices. So certainly in home networking land, a lot of these functions are actually combined, or can be all of these functions, can be combined into the one device. You may have a wireless modem, ADSL modem router, that performs all of those functions in the one piece of equipment. So it's a modem, you plug your phone line into it, it can act as a switch because it's got network ports that you can plug wired devices into. It performs as a Wi-Fi router to pump out wireless signal to connect to your network and share your internet connection. So in home networking, all of those functions are performed by the one piece of equipment. But in more complex enterprise networks, they're often separate pieces of equipment to do those sorts of things. But the functions remain the same.